Hi, folks. I thought I'd start off about showing you a little bit about the basic setup and the hardware and the software. So the first thing you're going to want to do, if you haven't done any Arduino stuff before, is go to the arduino.cc website, and you'll need to download the software. So I have already done it on my computer, so I'm not going to do it again, but I'll kind of walk you through this. So under software, there's different versions of it for different types of machine. I've got a Windows machine, so I downloaded the Windows. So if you click on these different downloads, it asks you for donation, and you don't have to donate. It's an open source software, and this is how they fund their program. So you can click on just download. So it's a typical install for any computer that most of us have all done before. So that's it. So install the software for whatever operating system you have. So I'm going to get out of that. I'm going to quickly show you a couple of different things that you might want to know about. So you can find all sorts of information about hardware, the different kinds of kits and boards. So I have a basic Arduino board here. You need a programming cable. The cables are sometimes different depending on which version of the Arduino you've got. The Arduino, this is a typical Arduino Uno version, so pretty standard for that kind of thing to get started. So install the software, and I'm going to show you a couple ways to get started. I did not learn this way as far as getting started the way I'm going to show you, but it's a pretty cool way to do it. So if I get back to my desktop, one of the tools that's real helpful is a program by Autodesk called Tinkercad. And Tinkercad has drawing capabilities and coding and circuits and so on. But it's really great for getting started with Arduino. So if we have a school network account, so I logged on, did all that kind of stuff. You can get your own account. If I go to the Circuits tab and tell it I want to create a new circuit, so this comes up, and you'll notice that there is an Arduino over here in the right-hand side of the screen. And that's fine. You can start with that and write your code and do that kind of stuff. And it's helpful to do it. But one of the things that's very simple to do is if I go up into this components pull-down menu here, and there's actually an Arduino tab. And so they have a whole bunch of the example programs that are in the example coding for Arduino already wired and simulated on these programs, and they actually have the coding for them. So the typical one everybody does is this blank one. And so the Arduino is set up so that it defaults to having pin 13 with an LED connected to it. So now in this wiring diagram, they have a 220 ohm current limiting resistor going from ground through the resistor to pin 13. So they have it wired externally. On the Arduino board, there's also pin 13 is pulled out, and there's actually an LED on the board. So you don't even have to wire this to make this work. So once I've pulled this up and got it ready, I could hand draw this. If you want to, move things around, you can move things around. And I can go to the coding. If I click on coding, it defaults to this block style coding, camel case coding, and it's fairly easy to understand. And if you're a project lead the way person, you've seen this before in the VEX person, you've seen this program before in the VEX coding. So it's similar to that. So what the block coding is saying is there's a forever loop. It's going to loop this structure over and over again, and it's going to turn an LED to high and then turn it to low, turn it high, and it's going to keep doing that over and over again. So that's the block type coding. If I hit the pull down menu, I can go to blocks and text, and it'll show the programming side by side. So if you're using the Arduino programming, where you're writing this C++ type code, this will download into the Arduino browser, and you can run this actual code. So what's nice to do is look at the code on the left and see what's similar about it on the right hand side. So it's an easy way to start to learn the coding. So you can see, just like on the other side, it's going to make an LED blink. And what is doing is pin mode, LED built in, which is the LED built into pin 13, and they're declaring it an output, and then they're turning the output high for 1,000 milliseconds, which is a second, and then digital write low for 1,000 milliseconds. So it's going to blink it on and off. So once you've seen the coding, you can start the simulation. So I'm going to start the simulation, and oops, I got to go back. So the simulation is running. You can see that the LED is blinking on and off, and that works great. Okay, so I can start and stop the simulation as I like. I can go back, look at the coding, and say, I don't really want to make it blink for 1 second. I want to make it blink a longer or a shorter period of time. So I'm going to go back to just the blocks coding. And instead of 1, I'm going to turn that to something larger. So it's going to be high for 3, off for 1. And so I can start the coding again. And you'll see it's on for 3, 1, 2, 3, off for a second, 1, 2, 3, and so on. So you can modify this code. So I'll stop the simulation. Once you've created the code in this, you can download the code. So it will download the Arduino code. So if I download the code, you'll notice it has the INO extension for the Arduino programs. And I can open this, and it's going to give me a warning, I believe. Nope, so once I have that, and I'm going to minimize my Tinkercad screen. Where are we here? Yep. Lost my, oh, there it goes. So there's my Arduino code. It's starting slowly. So while that's loading, I'm going to plug in the USB cable to my Arduino. And I'm going to plug it into a port on my machine. And it's going slowly. I may have to stop that and try again. So I have it plugged in, and you'll eventually be able to see. Okay, so it needs to be. So I just said, okay. So here's the code I downloaded from Tinkercad, and if I open it up, you can see it's the same as what was going on in the Tinkercad program. And so the next thing you need to do when you first start this is you have to make sure the Arduino software knows which version of the Arduino you have, and it also has to know what port you're on. So if I go up to Tools here and select, let's see, Board, and now because I'm using a whole lot of different versions of the Arduino boards. Most recently, this Adafruit Feather I've been using. I have a whole bunch of other Arduino boards listed. For the simple Uno, which is under AVR boards, if I scroll over, click on Uno, come on, there we go. So it knows it's an Uno, and my computer is working very slow today. Come on. Then I can go to ports and look at what ports it's detected, and it says it's on COM 8. So it knows it's on COM 8. And so then the next process is pretty simple. So I'm going to, you can check your code for errors by just compiling it. So that's the first. It won't upload it to the board, but it will check things like whether you've got, it'll show you errors if you got brackets out of place, you left a semicolon off, all that kind of stuff. If you're confident in your code, all you have to do is hit this arrow and it will upload it to the board. Notice in this lower left-hand corner, it says compiling sketch. So it's going to go compiling sketch, and then once it thinks about that for a minute, it's going to do uploading. And this may take a little while because my computer's running slow again. And once it's uploading, if everything is coded right and the hardware is plugged in correctly, all that kind of stuff, it'll say done uploading. Okay, so uploading now and then done uploading. So now, if you look at the program, and this is probably going to be hard to see on the computer, right here on my Arduino Uno board, the pin 13 LED is flashing. So hopefully you can pick that up on the computer screen. So I went from simulation to real world doing this kind of programming. So let's look at some other things that are possibilities. So I'm going to minimize my Arduino screen, and I'm going to go back into Tinkercad. So one of the things that I think is helpful, and the Arduino people said this in the first video, is looking at somebody else's code is very helpful when you're learning this. And I am by no means a good programmer, so I kind of power through this when I'm doing things. So if I go back to the Tinkercad and create a new circuit, and I'm going to go back to the Arduino basics. So this presentation is a little bit about doing some kinds of sensing and control. So the simplest kinds of sensing are things like push buttons. You can, in some of my other devices, I've used opto isolators for inputs. I've used photoresistors for inputs. I've used potentiometers for inputs. I've used, if you can think of it, you can use all sorts of things. But the simplest thing is really some kind of a switch or push button. So one of the nice things over here on the left is there's a whole bunch of examples of different kinds of input. So if the simplest one, this one's called button. So I'm going to drag that one over. And so I don't know how many electronics people are in here, but right now, this circuit is wired with a push button in it. And this is a 10K ohm resistor to ground. And then we have a wire coming up here to pin 2 input. So what this circuit is meant to do is send a signal to pin 2, either a voltage or a ground. So this is a pulled down resistor, so it's going to make this low or a 0 to start with, and then when you press the button, because current will flow in the path of least resistance, the voltage will flow up to pin 2 and then not through this because there is a 10K resistor blocking the way essentially. So, and it's pretty common, simple electronics to do this kind of thing. So you can probably imagine that if I can press a button, I can also not only control an LED or something else, I can also get it to control a motor or control a solenoid or some other kind of device. But this is a good starting point. So if I go to the code, and again, it's the camel case. It's telling it's going to read the push button value on pin 2. And so if I start the simulation, oops, I got to get the serial monitor to go. So Arduinos have what's called a serial monitor, and I'll show you where that is in the actual Arduino program. So I get the serial monitor open here. And if I start the simulation, you should notice that, come on, we're kind of slow today. So if I press the button, not reading my code. That's always fun when it doesn't do what you want it to do. Oh, okay, sorry. So I misspoke. So this one's turning the LED on and off and not the serial. I'll get to the serial monitor in a second here. So pressing the button turns this pin 13 LED on. So I'm going to stop the simulation. I'm going to go to something new, create another circuit. And then what's cool is they use exactly the same wiring for 2 other circuits. So there's digital read serial. And notice that the wiring for this is exactly the same. So they have the 10K resistor, a push button, and it's wired to pin 2. So what this is going to do, so if I go to the code, it's going to print to the serial monitor. So when I did my original pickup winder that I demoed, or going to demo, I'm not sure where this is going to come in the order, I used the serial monitor to display the numbers I was going to get. So it's same basic input, which is a push button wired to power and ground, and it's going to create a high or a low signal. So if I start the simulation, get serial monitor up. If I start the simulation for this, notice the serial monitor is 0 right now. And if I come over and click the push button, it goes to 1. So 0, 1, 0, 1, 0, 1. I can go back in, and if I want to change the something about this, I can put time delays in. I can do all sorts of interesting things. So there's another example of using the input. So lastly, one of the problems with using switches in devices that count pulses is that it's an electrical signal. So when you press a button, or in the case of like the opto isolator I'm using, the electrical signal will bounce. So if you were to look at it in an oscilloscope, it wouldn't be on and off. It would be on with a flutter and then off. And that flutter creates a problem with your circuit, and it makes counting for any kind of sensor or picking up a signal a bit problematic. So one of the things they do for that kind of problem is they do what's called debounce a switch. So notice again, this is exactly the same circuit again. And if I open the code for this, it's coming up to the Arduino coding. And the reason for that is that in the basic simulation or the basic program, there's not enough programming commands in the camel case to be able to really do this. So what this is doing is it's introducing a bit of a time delay to read the button. so it's not reading the bounds. So this is pretty complex. It's using different kinds of variables and setting them to different values so that you can change the length of time that the bounce is working. So you can go from very simple to really pretty complex stuff by using the Arduinos. So that's really basic stuff. I'm going to try to, in my next presentation or next little video, I'm going to move on to some of the outputs like motors.